Okay, gentlemen, here we go with 5.4 day 2. Again, we're factoring a quadratic in standard form when the a value is 1. To start off, we're going to look at an example of a trinomial that's easy to factor and explain why. So one that comes to mind that's very easy to factor would be a perfect square trinomial. For example, x squared is a perfect square, and the third term can be a positive 9. Middle term would be 6x. Why is it easy to factor? Because I simply need to square root the x, and I get x. And I need to square root this 9, positive 9, and we get positive 3. And that's a very simple one to factor because it's easily recognizable, just given the fact that the first term is a perfect square and the last term is a perfect square. I also need to be careful or conscious of the fact that the middle term being 6x, will that result from this? And I know that's x plus 3 times x plus 3. So we do know that we're going to have x squared plus 3x plus 3x again, and that's where I get my 6x. And of course, positive 3 times positive 3 is times positive 3 is 9. So the reason why that's easy to factor is because it's easily recognizable and it's a perfect square trinomial. All right. Two integers, find two integers with the given product and sum. We had this in the last lesson, so this is again just a recap. If the product, again product being the answer to a multiplication question, the product, so two factors multiply to get the number 48, and those two factors have a sum. When they're added together, their sum is 14. Well, I know 6 times 8 is 48, and 6 plus 8 is 14. If the product is negative 15 and the sum is a positive 2, I know my two numbers have to be, one has to be positive and one has to be negative, because when I multiply a positive and a negative, I get a negative. 5 times 3 is 15, and if I have a a positive 5 and a negative 3, that has a sum of positive 2. The product is 2 and the sum is negative 3. Well, if I look at the factors of 2, 1 times 2 is 2. And 1 plus 2 can equal 3. In this case, the product has to add up to a positive, the product has to multiply to become positive, but the sum, when I'm adding, needs to be negative. In that case, the negative 1 and negative 2 multiply to get me positive 2, but they add to become negative 3. So my answer is negative 1 and negative 2. And like I described in the last lesson, it does not matter which order we write these in. Okay, just looking at factoring again, we're looking at potential values for b. So if we're going to factor this, again, we look at c, we look at this positive 12. I'm looking for two numbers that multiply to 12, but also add up to this middle number. In this case, we're giving it the letter b, and what can b potentially be? Well, one thing you want to do is look at the factors of 12. So if I'm looking at 12, I have 1 times 12, 2 times 6, and 3 times 4. So I could have, if my answer is positive 12, I could have a positive 1 and a positive 12 as my factors. And so I could look at that as my two positive factors. And if the answer indeed is 1 and 12, then b could technically add up to 13. Because 1 times 12 is 12, but 1 plus 12 is 13. b could also be 2 plus 6, which in this case would be 8. So b could be 8. And then my last example, 3 and 4, so b can actually be 7 as well, because 3 times 4 is 12, but it adds up to 7. In the next example, we're looking at positive 18. Factors of 18, 1 times 18, 2 times 9, and 3 times 6. But this time we have, you'll notice, a negative b. So what two numbers will multiply to positive 18, but when added together are negative? Well, we know two negatives multiply to become positive. So I could have a negative 1 and a negative 18. In that case, the sum would be negative 19, but when multiplied, negative 1 times negative 18 would give me a positive 18. I could have a negative 2 and a negative 9, and that would get me that would become negative 11 if added together. but again, they multiply to get me positive 18. And negative 3 times negative 6 are two integers. When multiplied would result in a product of positive 18, but when added together have a sum of negative 9. So another option here is it could be negative 9. The third example, we're looking at negative 15 and a positive b value. Well, the factors of 15, 1 times 15, and 3 times 5. Now, you'll notice there are 4 blanks here. There are 4 different options, because when we're multiplying to get a negative, to get the negative 15, I could have a negative 1 and a positive 15, or I could have a positive 1 and a negative 15. And either of those will get me a result, a product of negative 15. So if we have indeed negative 1 and a positive 15, then our answer will be negative 14. But if we have a negative 1 and a positive 15, we're looking at a positive 14. If we have a positive 1 and a negative 15, then our answer is going to be negative 14. Similarly, if we have a negative 3 and a positive 5 as our two terms, then we will have a sum total of positive 2. But if we have a positive 3 and a negative 5, again, negative 5 and a positive 3 will multiply to negative 15, but the sum total would be a negative 2. Okay. And again, if you were factoring that last one, if we had x squared plus bx minus 15, and let's just say that we're using negative 14, so x squared, erase that right there, x squared minus 14x minus 15. If you were factoring that, we would simply have x here, and we'd use our two, the negative 14, again, you'd have a positive 1 and a negative 15, so positive 1 and negative 15. And that would be your factored form of that. Okay, x squared minus 25 is a special case. That's why it says these are special ones. You should recognize that as a difference of squares. This here is a perfect square trinomial. And I gave you an example of that way up at the top here when I had asked for an example of a trinomial that's easy to factor. I purposely chose a perfect square trinomial. A difference of squares is easily recognizable because you have a perfect square and a perfect square and separated by subtraction. So the square root of x, the square root of x squared is x, and the square root of 25 is 5. So those are going to be our terms, and one's going to be addition and one subtraction. Why? Because we need the middle term to cancel each other out. So we know x times x is x squared, and x times negative 5 is negative 5x. But then in the very next step, you'd have 5 times x, which is a positive 5x. So the negative 5x and the positive 5x would be like terms, and when added together, they eliminate each other. And then the last term would be 5 times negative 5, which of course is your negative 25. The perfect square trinomial, equally easy. Again, I gave you an example above. So we'd have x as the square root of x squared, and our last term is 25. Now notice, I'll use a different color here. Notice that we have a positive 25 and our b value is negative 10. So we're looking for two numbers that multiply to positive 25 and add up to negative 10. In that case, we know a negative 5 times a negative 5 is positive 25, but a negative 5x and a negative 5x add up to negative 10. So this is negative, so x minus 5 squared. And that's a perfect square trinomial. Again, it also looks like vertex form. So what we've learned is when we factor a quadratic that is in standard form, we can end up with vertex form if it's a perfect square trinomial. All right, in this case, we have a positive 25 and the b value is 10. Again, the square root of x squared is x, and the square root of 25 is 5. In this case, it's also a perfect square trinomial because the first term is a perfect square and the last term is a perfect square. And we also know that this works out x plus 5 squared is x plus 5 times x plus 5. X times x is x squared. X times positive 5 is positive 5x. 5 times x is also positive 5x. And 5 times 5 is positive 25. And these two like terms add up to positive 10x. So x squared plus 10x plus 25, which is what we have in our question. And the factored form of a perfect square trinomial looks like vertex form. Okay? All right. Good luck with your homework, and we'll see you in class.